All right, we're going to go ahead and get started. Thank you all for coming today. I really appreciate you taking the opportunity to come and hang out with us for a little bit instead of going to see SecNav. I do a little counter-programming here, so hopefully he doesn't say anything, something very revolutionary and we've all missed it. But I don't expect that's going to happen. But yeah, I'm Brian Clark from the Hudson Institute, and I'm the one pestering you with emails over the last several weeks. Also with me are Tim Walton and Dan Patt and David Bird, all from Hudson Institute. We all work in the Center for Defense Concepts and Technology at Hudson, where we focus on, as the name implies, the intersection of defense concepts and new technologies, what that means for strategy and operations of military forces. So I want to talk a little bit today, like I said in the email, about a few of the studies that we've been pursuing and getting ready to publish over the last couple of months and over the next few months, and highlight a couple of areas where some of the work you're all doing has been very important to pushing these ideas forward and advancing U.S. military capabilities. So I want to talk a little bit about some studies that we've been publishing and are getting ready to publish this year. I want to start with the one that we published early this year, looking at the future of the U.S. Navy fleet and the U.S. commercial fleet. Mike Roberts and I did this. Mike did a lot of work here where he's been a leader in advancing the Ships for America Act and pushing forward the expansion of the U.S. flag commercial fleet. And really the rationale behind this push has been something we're all familiar with, which is China has been dominating the world's commercial shipbuilding production over the last decade. They've certainly ramped that up, as you can see on the chart here, dramatically in the last few years. The green blobs, those are Chinese ship orders and ship construction over the last several years. And you can see it's really taken a dramatic upturn of late. This is driven by a lot of their predatory practices that we're familiar with. So government subsidies, support to their shipping companies to help them defray the cost of buying new ships instead of continuing to operate existing ones. And then looking to try to gain market share around the world. And that's really hurt our allies in particular. The U.S. shipbuilding industry, as you all know, is vastly smaller than China's, vastly smaller even than our allies, Japan and Korea. It's hundreds of times smaller than all those countries' shipbuilding industries. So the Trump administration and the Congress are both working to try to expand U.S. shipbuilding through actions like the Ships for America Act. Why this is important is because we have this pretty substantial gap between what we need for commercial ship capacity and what we have when it comes to military operations. So on the left side of this chart is the tanker gap, if you will. The number of tankers that we think we need for future military operations, which is that red line with the arrow that's going up, meaning it's only going to increase. And then you can see where we stand in terms of available shipping. And the blue and the dark green areas at the very bottom, that's what we actually have access to on a day-to-day basis. The rest of it all is something we're going to have to get, tankers we have to get from the commercial world and charter and hope that they're available when the time comes. So there's a huge gap in terms of our tanker capacity and where we need to have it if we were to get into a major conflict. On the right-hand side shows the gap we have in cargo capacity. Not as substantial as the tanker gap, but pretty substantial still. And if you look at the bottom there, the ships that we have in the U.S. government today, in the Maritime Administration's Reserve Fleet, in the Maritime Sea Lift Command Surge Fleet, those are very old ships that are being recapitalized very slowly. So that bottom part is a lot less available than we think it is. So there's actually a much larger gap there on cargo capacity than we think there is. So having a bigger U.S. flag fleet is essential to closing these gaps in case we need this for a conflict. So the Ships for America Act, which we advocated inside the study for and is coming back up again in this Congress, does three big things to try to address this gap. One is it creates this new strategic commercial fleet that's going to put a lot more ships under U.S. flag. There's competitive bidding to provide subsidies to companies that run those ships so that they're able to defray the cost, offset the cost between operating a U.S. flag ship and one that's foreign flagged, because you have to hire U.S. mariners, you have to operate under U.S. regulations, that's more expensive. The second thing it does is it phases in a requirement over time to make those ships be built in the United States. So that's going to increase demand for U.S. shipbuilding. And again, there's a subsidy to help defray the cost of building in the U.S. versus building overseas. Right now, a lot of the ships that are under U.S. flag are actually were built in China. So that's a challenge that we're going to have to come through and try to get to the other side of. And then the last thing it does is it tightens some regulations on who carries cargo for the U.S. and into the U.S. So you heard recently the Trump administration put some new tariffs and fees in place for Chinese ships calling on U.S. ports. This act would expand on that by requiring that a percentage of exports of crude oil go on U.S.-built ships. So again, driving a demand for U.S. shipbuilding. So this is all going to expand U.S. shipbuilding. It won't close any of the gaps, and we're still going to be hundreds of times smaller than China probably. But it'll make it so that we have a shipbuilding industry that can provide resilience to our U.S. naval operations and will provide a bigger U.S. flag fleet to support future contingencies. Now, on the Navy side, which is kind of where we focus a lot of our attention, the Navy's future hybrid fleet, which, there's a representation of it up here that they're driving toward, is going to be a much different fleet than we see today. The costs and the personnel required for today's fleet is just not sustainable if you try to take that forward into the future, because we already see the cost structure as being unaffordable. Also, we're going to need to add a bunch of new platforms to the fleet to get to the capacity we need, but also be able to deal with the future operations we're likely to face. So contingencies like a Taiwan, where a lot more uncrewed systems might be very important, or long-range, long-endurance systems that are able to operate in the Indian Ocean. So this core force of today that you see here is going to shrink over time to become a smaller version of what it is now. And what we're going to see instead is the expansion of a lot of new platforms. So the growth in the fleet's going to be in these new categories of platforms: uncrewed vessels, uncrewed vehicles that are contributing a lot of the reach and persistence to the force. So you can see some examples that are up here that the Navy has already fielded, or with DARPA, I guess. The NOMARS platform, which is a relatively large 300-ton medium uncrewed surface vessel, which could carry munitions, weapons, launchers, logistics, et cetera. And then on the upper part of the slide, you can see Saronics got a couple of vehicles, I think one of which is now on display down at the pier here. And Rob Lehman, you're here from Saronics, so if you want to talk a little bit, can we get the microphone, about what Saronics doing, and you can give us a kind of a preview of what's going on with Corsair down on the waterfront.
Just a quick overview of the company and what we're doing. Not trying to give a sales pitch, but it's valuable background for the slide. So we're a defense technology company, and our mission is to redefine maritime superiority for the U.S. and our allies. And we're approaching it through unmanned surface vessels, but we're doing it in a differentiated way from most of the other players in the market, where we're taking a vertical integration approach. So before you raise concerns about vendor lock, I'll get to the MOSA standards and how we've architected the boat to integrate into both current and future architectures and payloads. But to bring it up a level, we do all of the boat design from the keel up to be autonomous from day one. We do all of our own software and autonomy, both single agent, multi-agent, collaborative autonomous behaviors, and all the manufacturing under one roof. Our third employee was our VP of manufacturing. So before we had a boat, before we had a sketch on a cocktail napkin, we were building the system that has to build the systems. We're seeing that play out right now, where when we get asked questions from customers about manufacturing readiness and parts traceability, they're shocked that at just over 2 years old as a company, we can trace every bolt, washer, down to the individual hole number. If we get a supplier who says they have a problem with a lot of their bolts, for example, we can go to a customer and say, holes 18, 36, and 52 are affected. Repair the new parts and the digital instructions so that you can make that replacement. Really, really hard to do that after you have your prototype built and you're going into production to try to build that process in parallel. How do we do that? At 2.5 years old, we have 400 employees, and we've raised $850 million. Not to bury the lead, that's how you do it. You have to have operational insights so that you know what you need to build, what the swap has to be for those platforms. You have to be able to convince investors that you have the relationships and the insights that you need, the ability to execute, and kind of the stick-to-itiveness to be a non-traditional. One of the phrases I always use is, with Saronic, you get all the benefits of a non-traditional defense contractor, but none of the training wheels required. And I think most people at this show probably understand, if you come in, blissfully unaware of how to do business with DoD, Navy, and NAVSEA in particular, your lunch is going to get eaten before you ever get started. So you have to understand what the puts and takes are for all the stakeholders involved. And what we've been able to do is, between being on the Hill early and often, it's what I tell all the people I mentor. If you're not starting the engagement strategy on the Hill on day one, you are behind the 8 ball. So we have 3 platforms in production right now: 6 foot, 14 foot, and 24 foot platforms. Different mission sets informed by different requirements, and more importantly, wants and needs. I think we've had the ability to talk to folks where, look, if we're not chasing the palm of the FIDP. We have to factor those into our thinking. But our if-then statements are in our autonomy. They're not in how we deal with the Navy. It's not, give me a design study and then I will make the investment to design this thing. It's, we think we know what you need. We're going to build it on our own dime, build a bunch of them. You tell us what needs to be tweaked, and you don't have to fund it. You just need to buy it on the back end. And obviously that's a much more relevant market approach on the smaller end of the spectrum. When you start getting into the NOMARS level, the MUSV, you certainly have to, your risk tolerance has to go up. And to that end, we are underway with building Port Alpha. After our Series C raise probably 2 months ago, we kicked off the search for a site to build the world's most advanced shipyard from the ground up. So we looked at, can you fall in on existing infrastructure? Can you fall in on an existing workforce? Those are options, but our mission is to give NAVSEA new options and a new way of thinking. And frankly, I'll say it, there's stakeholders that you have to drag kicking and screaming to change the way things are done. And there's no offense intended. This is a collaborative approach of saying, look, we have to read the room. Every time I'm on the Hill, everybody says it's broken. And if we saw testimony last week, it's not just the shipyard's fault. And we have to find a new paradigm, and we saw the unmanned space as the ideal entry point, because it allows us to bring new capabilities that allow us to remain payload and effector agnostic, C2 and COP agnostic. We've already integrated a ton of systems and programs of record onto the platform, and we are batting 1,000 on sub 72-hour integrations. Those are large-scale C2 architectures. Those are a variety of different effectors, and it's a testament to what can happen when you have the ability to get informed on wants and needs. Like, hey, I don't need to know what's going up to N96. I mean, I do, but what's really important to us on the front end is go talk to a SWIC or go talk, to a JO and find out, hey, what's the Commodore rogering you up for that you have to say thumbs up, and when he walks out of the room, you look at each other and say, how are we going to execute that? We don't have the tools, and we've all been there, right? Everybody in uniform has been in that environment. So those are the valuable pieces of info for us that allow us to make the design decisions, and then we make a commitment and we lean in hard with capital so that we have all of the long leads and all of the things we need to scale very rapidly. It's a huge risky play. Look, we're essentially taking the same VC model that our investors take when they invest in companies. You have to dial in, learn as much as you can, and freaking go. And that's the approach we're taking. We engage customers, Hill, exactly the same. Look, there's no plan B. Someone has to do this. We're manned, trained, and equipped to operate in this environment. And there's a reason my hair is so short, because it would be very, very gray. 2.5 years is a very, very short turnaround time to have the infrastructure that we have in place, the employees that we have in place, that are typically not in the maritime space historically. So VP of Manufacturing, 10-year direct report to Elon Musk, ran the Raptor engine production program for SpaceX. Our Corsair production lead, who runs the line, Tesla Model Y production lead. So these are folks that you have to bring in. You have to be open to new approaches. And when you think about NAVSEA standards, how do you work with the tech warrant holders and the other stakeholders to say, it's like ABS or less? Why are we applying standards that aren't, they don't apply to an unmanned platform? So instead of starting with the gold standard and moving down based on a lot of leverage that's painful to get applied. How do we start from the bottom up and get the right balance between life cycle cost, capability, flexibility, and exportability? So the slides on capacity, that's really our mission, is how do we, if we can build a couple Corsairs, we're all on LinkedIn, the ecosystem in the small USV space is just a huge echo chamber of a bunch of companies that have a couple things and are saying, give us a contract and we'll build more. None of this matters if you can't deliver hundreds and thousands within 12 to 18 months. If you can't, the relevance of those platforms stay in very small numbers and you can't build a business around it. You certainly can't build one that scales. And that's where, when we looked at Port Alpha, how do we take kind of the principles that we brought to the SUSV space and apply them to the M and L and the commercial space? So we are anti-heartbeat. We build from the keel up, no human accommodations. Now, when we go to the larger and larger vessels, we're going to get dragged kicking and screaming to make accommodations. But I'll tell you, our starting point is, if there's a human on there better be a porta-john on the deck, because you're making a compromise on a craft's capability and you're giving up some of the benefits of unmanned the second you put a human on board. So machinery control, really, really hard problem. That's why we're bringing kind of some technologies and people who haven't been in this space. So how do we kind of change the paradigm? We're eyes wide open that this is a hard problem. We're not saying just dismiss everybody who's been in shipbuilding and they're messed up and we're great. So we're candid with ourselves. We're bringing in the right talent. We're asking for help where we need it. But at the end of the day, you have to be willing to spend what some large primes have on their balance sheet on IRAD at risk. And that's what the VCs allow us to do, is we're authorized to do that. We're asked to do that. They don't give us the money to put it in a money market account and have it grow. We're supposed to deploy the capital and change the game. So it's a really exciting time for us. I think the engagements with the Navy have been great. I mean, I would love it if it was not a near-peer competitor that was driving this requirement to adapt. But exigent circumstances require rapid movement, and we do feel, as a company, our CEO is a former DevGru SEAL, I'm a retired Marine. We've got a big balance of prior service. We do have a bunch of SWOs too. Prior service, so we understand kind of the need. And frankly, these are our friends who are going to go be inside the WES. So we take it really seriously. This isn't a marketing campaign, and it's certainly not smoke and mirrors. So if anybody questions kind of our capacity, ask anybody who's been to our site, and they can let you know what we're capable of.
Thanks, Rob. And so one thing I was going to ask you about is the ability to dramatically ramp up production. So if we get into a situation where the government says, what I have on the screen is sort of what the Navies might be looking at in terms of a steady state number of these vehicles or vessels, which is substantially larger than where we are today. So it is scale. But what if they say we need thousands? We need like Corsairs, or we need Spyglass in particular in the thousands to be able to use them as one-way attack weapons. Could you farm this out to other places where you could expand that manufacturing base?
Sure, yeah, I mentioned the US and our allies at the very beginning. So all of our platforms are designed to be as exportable as possible. When you go up into the perception system and some of those capabilities, it's interesting, the demo out at the pier is very, very dumbed down for obvious reasons. But the platforms themselves, when we look at our supply chain, whether it's prime movers, any of the sensors, any of the HME components for that matter, we look for exportability and supply chain resilience. I used to represent a client in the UK, understand offset, how ITAR, FMS, and EAR certifications work. So exportability's been baked in. I think the real challenge is, A, how do you have your supply chain vetted and locked in on the front end? If you don't have a DX rating on your contract, how do you ensure that you get front of the line privileges ahead of when that DX comes through, right? And honestly, how do you get, if you look at the MUSVs, there's a set of prime movers that NAVSEA says are okay, and a whole bunch more that NAVSEA says aren't okay. So if you're Caterpillar or Hamilton Jet, how do you incentivize them to make sure all of those transmissions and prime movers are available? So I think the Navy needs to send a signal that allows companies to pre-buy inventory and be willing to take that risk where, okay, if you don't get the contract, at least you've got, a part of the, the ecosystem. So it's a big challenge, but I think prime movers is probably the biggest one. Those long lead items, how do you get companies to build them ahead of requirement and PO, and then how do you get the people who are going to buy them to integrate them to pay for them pre-PO?
Right. We'll talk more about that in the weapons discussion too. So thank you, Rob. I appreciate it. And so to your point, one of the big challenges here is the standards process. How do we apply technical standards to turn a top-down requirement into a detailed specification? So that normally, we start with some highfalutin ideas about how we want the system to operate, what we want it to do. But over time, as it goes through the NAVC process, it becomes this very detailed technical specification that now you're telling the manufacturer exactly how you want it to be built. You're probably prescribing a lot of details that are going to preclude them using a wider array of suppliers to support the platform. It reduces the scalability of it, also reduces its adaptability and resilience. So getting away from this idea of applying these technical standards so rigorously or compulsory in a compulsory way, especially to uncrewed systems where we do have a much more open aperture, or we should, in terms of how do we apply technical standards. This will be really important to get the scale that we would need in the future fleet. This may not be as important if you're looking at crewed ships or submarines or even crewed aircraft, but certainly in uncrewed systems, we have to be able to have a wider potential range of specifications that could be applied. And it means using standards that are coming from outside the Navy's existing mil standard library. So this is something that the government's actually actively working on. We met with NAVC a couple weeks ago. They're working on this, trying to improve this process. I know the White House's Office of Shipbuilding is also working on trying to change how we approach the application of technical standards. And then ship repair is another area where we see a lot of improvement being needed. I won't go into detail here, but just to suffice it to say, you can see the demand signal from the Navy is very uneven, and if you're on the East Coast, it's actually declining because of the shift of forces to the Western coast into the Pacific. But generally, the Navy's contracting process and planning processes are not really adequate to prepare a ship repair yard to be able to do the work that they're expected to do. So they're always playing catch up, both in terms of material as well as in terms of getting their workforce and infrastructure prepared for the upcoming availability. So if you're in this business, it's not a great business to be in terms of return on investment. And so the Navy's got to make some pretty dramatic changes in how it approaches the management and the contracting of maintenance availabilities to do it over longer periods of time for multiple ships at a time and make this a more sustainable demand signal for industry. So I'll stop there, and if there's any questions on this, we can address those later. But I'm going to step into another study that we just released. This one looking at the munitions industrial complex, if you will, and how we can approach munitions production differently, and how we're going to need to in preparation for large-scale conflict. We've obviously heard the discussions in the press and from the government about how our munitions inventories are inadequate. You can see on the right-hand side, it's kind of small print, but to get just the relatively low-end weapons that they're using in Ukraine manufactured, the lead time is years to be able to get them into production. If you looked at the same chart for some of our preferred munitions, like the SM-6 or the JASSM or the Tomahawk, it'd be a similar chart. You'd have years-long delay periods to get the supply chain spun up to support increased production levels. And this is in large part because we've built these to be very sophisticated weapons, very specialized supply chains. They get locked in relatively early because of the application of standards like we talked about before. They get qualified with those standards in place, and it's very difficult to modify the components. So as components go out of date, new components can't be brought in very easily. You're continuing to having a set of specialized manufacturers build the old part because the new part can't be brought in. And so all this contributes to those preferred munitions not having the ability to spin up production dramatically because they have these very specialized, highly integrated designs. So we thought one of the bigger drivers behind this was this focus on building the best possible weapon every time. So we've got to maximize the performance of the weapon just in pure speed, kinetic capability, and seeker capability factors. So if you drive towards the best weapon every time, you force yourself into a very specialized design that is going to be probably highly integrated. That's going to probably not afford the ability to adapt it later on. And we need to think about maybe different metrics being important to munitions production in the future. So things like, can it be scaled? Can it be adapted? We already see in Ukraine how weapons are becoming obsolete because of GPS jamming, like the JDAM or the Excalibur round. So if we can't adapt a weapon, it's going to be irrelevant. So adaptability and the ability to scale are probably much more important metrics to apply to new weapons than just the pure performance in terms of how fast they go or how big a warhead they carry or how good their seeker is. When you think about changing the metrics that you apply to weapons production, then that allows us to open up the aperture in terms of how you design them. So modularity becomes an option if you're not focused entirely on pure performance. And my co-author here, Dan Patt, brought this idea into the study as well. But using a modular design allows us to now mix and match different components, gives us some more supply chain flexibility, gives us the ability to maybe manufacture these in facilities that are not designed around only building that one weapon. If you're building something that's in a modular construction, you don't need specialized training to be able to put it together. You're just assembling parts as opposed to hand wiring things like they do if you look at an SM-6 plant or a Tomahawk plant today, they're hand wiring a lot of those munitions because it requires very specialized, highly integrated design, which is up at the top there. So instead of the highly integrated design at the top, we go to a much more modular, loosely coupled design on the bottom. There is a performance tax that you pay for that because now you're giving up space, weight, and maybe configuration control that would otherwise make the weapon that much better. But the benefit is you get scale and adaptability. So a great example of that, is the JDAM, which you can see over time went from just being a bomb to now being a powered JDAM. And they're using versions of this in Ukraine. They've adapted it to deal with the GPS jamming with a home-on-jam capability. So we've gone from a weapon that was designed originally in the early 90s to address the need for precision weapons at scale to now something that you can get scale out of but gives you range and the ability to defeat some of the countermeasures that are being employed today. The other part of modularity is the software modularity. I think sometimes this often gets lost in the shuffle is you've got to not just build the parts to be physically modular and have interfaces so they can connect up inside the frame of the weapon, but you also have to build the software so that they can plug and play using APIs, just like we see in modern software applications like on computers and phones. So the model that we use in these highly integrated weapons on the left-hand side essentially compiles all the software inside of each of these components, and then you compose the components together, and you have to basically write new software code to integrate them all together because they weren't built to be modular. They aren't self-contained, or they rather aren't built to interact with each other. They're all self-contained units without the ability to interface with other components. The model we have to go into instead in a modular approach is you build all the components with software interfaces built in that allow them to basically have APIs so that they're able to interact with their fellow mission systems or with the weapons control systems. Obviously, there's a tax, again, you pay here, where if I don't highly integrate the software and build it all in one big stack, I'm probably giving up some performance benefits that I might have had otherwise. But the benefit here, obviously, is that you can mix and match these much more easily than you could the highly integrated approach, and you get that scale and adaptability again. And so Dan brings in this great case study of the F-117, which was in a lot of ways a Frankenstein sort of cobbled together aircraft with parts from a lot of different aircraft that were put together to allow it to be built quickly, because that was the goal, and also to achieve the main objective, which was be stealthy enough to reduce its likelihood of being detected, but giving up a lot in terms of performance because they needed to get it done quickly and they wanted to use available components. So you can see they gave up a lot in terms of what they wanted versus what they actually got in terms of performance on the right-hand side there. And it's because in large part they cobbled together a bunch of existing systems and then used ConOps to take care of the rest. So the ConOps for the F-117 adapted to the fact that it didn't have a really good, or didn't have a radar at all, I guess, on it, and didn't have the performance that you would expect out of a traditional fighter aircraft. Whoops. So this sort of drives you to what this all is revolving around is this new model, essentially of program management that you would have for these weapons. If you're a modular weapon, instead of thinking of having a performance characteristic that you're trying to achieve, and then basically your program management triangle is cost, performance, and schedule, and then performance is basically fixed, and then cost is usually fixed by the budget you get, and then schedule is the only thing you can manipulate. Instead, we need to think about the three things being: how quickly can I reach relevant capability, with the F-117? Can it be good enough to deal with the situation I'm facing today or that I anticipate facing? And then how long does it take me to reach a relevant scale? So to Saronic's point, how quickly can I ramp up production to the level where it's going to be relevant? Because if I can't build more than, if I only build 10 of them, that's not useful. If I could build 100 of them, that might be useful. So I'm going to have to give up in terms of characteristics for performance. If I want scale, I'm going to have to give up characteristics for performance if I want relevant capability now. And then the variable here, like we saw with the F-117, is the operational concept. So that's a thing we can modify to be able to take advantage of the scale and adaptability we can get, but accommodate the reduction in performance that we're likely to have to live with. And so I wanted to turn to General Atomics, ES, because they're working on some capabilities now that are relevant here. I think you just announced the partnership with Rafael on the Bullseye weapon, and then also long-range maneuvering projectile, which reflects some of these ideas of modularity and using available parts and having ability to ramp up production. So, Tim, do you want to talk about that, or?
I would love to talk pointed
Okay. And Mike Rucker's here too.
Hi, I'm Mike Rucker. Yeah, I'm the Vice President of Weapons Systems at EMS. So yeah, I'll start with LRMP because there's a lot of things that Rob just said that we took advantage of with the long-range maneuvering projectile, and that is, we're privately held, so it's not VC, but it's Mr. Blue, who got really passionate about developing this long-range projectile that gave this capability to go after Ukraine and the weapons, the systems in Ukraine. And at the time when we started this program, we were lining up to work with the Army program and try to get funding from the Army, but the Army started diverting funding to support the munitions resupply, typical 155. So he said, what do you need to go fast and just do it yourself? And the thing that I found out was when you take the services out of the equation, you can go really quickly from a requirements perspective. You can just take something that's not going for the full up capability, like you talked about, and deliver a Block 0, a lower end capability. And what we started doing, though, is about halfway through the program, we started standing up what it would take to do manufacturing and testing machine cell capability. He wanted to know how many of these could be built in a year. We don't know, we haven't built them before. So we stood up a manufacturing capability in parallel with the design effort. So we're making changes for manufacturability now, even though we haven't even delivered the Block 0, to find out, can we build 100 a month, 1,000 a month, whatever. So we bought machine cells, CNC machines, set up machine cells, robotics, et cetera. And we're, at the end of this year, beginning of next year, we'll be standing these up to say, yeah, you can make 100 of these or 1,000 of these a month. And then if we have to scale up later, we can just say, you got to set up one of these cells here. We got to set up one of these cells overseas. That gives you the quantity discussion. Before you even deliver the capability, you're making changes for design for manufacturability, which is really an interesting approach to this. I've been doing development programs my whole life, and you always deliver the capability, and then you start going, oh man, I can only make so many of these things, right? So to flip it and look at manufacturing as you're doing the development is a great way to get a sense of surge capability, how you're going to build it. And then talking about the Bullseye, this is a partnership with Rafael to bring a affordable modular system. Modular again. If you look at this thing and look at volume space, you got the seeker space, you got warhead space, you got fuel space. That's how we looked at this and the interfaces. So that if you need to change capability, you're changing at that modular interface level, not something that's integrated that goes out through the whole missile. The other thing that's really fascinating that I think is what everybody needs to be looking at for weapon systems going forward, for just the structure of the flight body, is kind of the canoe shape where you can drop kits in, you can open up the system. It's not just the interfaces, it's the access to the subsystems that you can get to, so you can swap something out easier without building a stack for the system. So thinking up front about scaling and modularity in the design phase helps. That's how the back end improvements when you get to the surge and try to address some of these issues that you're talking about. If we end up going on a war footing, how do you quickly do this? Well, you've already tested the cell capability. You already have the modular systems. You can just drop in different components, and you can quickly get to a quantity that the nation needs.
Thanks, Mike. That's a great point, and it's a great lead into the next element of this, which is how do we how do we get to massive scale? And to your point, I was going to ask you in a second about what kind of scale you might get and how this might be outsourced. And this is the question I asked Rob as well, is in the past, like World War II, when we had to rapidly scale up military production, we turned to commercial industry. So commercial manufacturers, contract manufacturers, they do this for a living. They rapidly build things at scale for designers that come in with systems they want to construct, whether it's a car charger or a dialysis machine or a microwave. And this happens in the U.S. This is not necessarily just a foreign phenomenon. And so here's some examples, but you can see where HP, for example, doesn't build any of their own computers now. The Quanta computer builds all their computers now, but HP gives them design. They work with Quanta to come up with a design that can be manufactured, to your and Rob's point, and then they build them at scale. Same with a company like Magna, who builds cars for Jaguar, Toyota, and Fisker. They work with that designer to come up with a design that works for the manufacturing process. And this is also what we did during World War II, where Ford built a bunch of airplanes that were designed by Consolidated Aircraft, who had great designs, but not necessarily the ability to manufacture them. But those designs also could not be built at the scale they needed. So they had to make modifications. So there's this need for design for manufacturability that you have to do with the manufacturing partner in a lot of cases, which I assume you guys have been doing. So one question, for you guys at General Atomics is, to what degree could you tap into latent manufacturing capacity that's either resident in the company or outside the company to engage another contract manufacturer, perhaps, to build LRMP or Bullseye at scale?
Yeah, so we have a manufacturing center in Tupelo. We've got significant hypersonics manufacturing there. We do our own manufacturing there. But back to this point of standardizing process and the CNC machinings and the robotics and the lights out operation. If you look at that now, we can do that internally, but our goal is to come up with essentially cells that we can then market and say, this is how you're going to do this, remotely. If we can't do the capacity, and we won't be able to handle that kind of capacity. If we go to this footing, we can't make our hypersonics and our projectiles and all those other types of things in our facility, but we will have the modularity, and we'll have here's back to Rob's point. Here's the digital manufacturing case of what a cell looks like, and we're going to stand this up in the UK, and we're going to stand this up in the UAE, other places like that. So we're taking our own lessons learned from our own case, and that'll be something that we license out if other people need it.
Right. Thanks, Mike. Yeah.
Sure. It's a great point. So great minds think alike. Our assembly line is intended so that we can essentially pull someone off the street and have them working on our platforms within 36 hours. So the system has so repeatable that the human terrain really doesn't matter. And you're making it so simple that, hell, I could come in, read the instructions, and I know exactly, here's my video showing me exactly where I screw something in. And that is something that you can then take and you can license it out of it, and others can build it. So again, but you know it as well, you can't do it after the fact if you don't architect that at the beginning host.
Right. Well, good. Thanks, gentlemen. I appreciate it. Yeah, go ahead, Ms. Ogg.
Just a quick question here. What do these machines do after the inventory ramp up, right? We're going to stack the inventory with systems, whatever it is, and then we're not going to continue to produce at those levels or buy at those levels unless we firmly believe that we're going to just keep stacking more and more inventory. What happens after that demand drops off with all of those machinery? So I get you could take a guy off the street in 36 hours, be up and running, but you still need the machines. Somebody's got to pay for those machines. How is all of that sort of finance taken care of?
Well, in the classic model which we're running right now, you know, if you have a full-up manufacturing capability, as I was alluding to, we'll swap these machines from making our hypersonic parts to making our projectile parts. That's sort of the classic way. You know, you're trying to do demand management, but I think in the future, what you end up doing is you stand up the line with your robotics, your tooling, your CNC machines, and you set up a program, and it's running that. And you hopefully, I mean, to make this kind of investment, you want a significant demand signal. That is true, right? If you run that line, it becomes a down situation for 6 months to a year. You just reprogram it. Now, you should be able to roll that in a week with setting up new tooling and reprogramming, and you can stand up a new line. But that is part of the overall challenge, is the demand signal we went back to. It requires investment. It allows you to plan for the horizon of 2 years to 5 years. But if your demand signal is, you know, less than a year, then it's a real challenge to spin up. The robotics and the automation part of it makes it easier to switch lines more quickly, but you still have to have a demand signal to really make the investment and to have efficiencies once you've set up those manufacturing capabilities.
Yeah, I know. So, yeah, you want to be, you know, the Super Hornet line, right? Like, that thing's never going to shut down. So I would answer your question with, part of this is just straight leg BD growth. You know, you've got to go build those relationships and manage that pipeline so that if a customer does want surge support and you're balancing multiple customers who want things, how do you ensure that you're working with them to make sure they understand how to right size? You know, if you want everything right now, here's what you get. If you spread load it, then, you know, here's what else you can get. So it's really a hybrid of traditional manufacturing. You captured it really well, right? You have to be, you know, agile enough in the machinery part of your production line to adapt, whether that's, you know, a new block variant of your platform because technology changed, or a different platform. If you're building up a separate line for each unique thing, that works in the cost plus traditional model where you're paid to build that. So if it does become no longer relevant, you aren't in the hole and just have something stagnant. You at least, you know, we're covered along the way. So yeah, our approach is, how do we do that demand management and frankly keep making big bets as we move up in platform size and different customer sets and ConOps to support. It's kind of you're making a bet. I don't think this market's shrinking. So we're, I guess, uniquely lucky in that there's an urgency behind getting these systems out there. So we're confident that, you know, whether it's one individual platform, a family of systems, and future systems that we're building, you have to keep that demand signal going. Otherwise, I mean, yeah, sales drives everything. So yeah, I look at my team, you know, in the eye every day and say, let's not think about 18 months from now. Let's think about 36, 48, and beyond.
Thanks, Rob. So the last study I'm going to talk about, because then Tim's going to talk about one, is the study we released earlier this year looking at the sensing and sense-making competition. This was done in support of some research that OSD R&E Research Engineering was doing. You're looking at how do we improve the non-kinetic supply chains. We focus a lot on kinetic supply chains. We just talked about kinetic supply chains. But DoD is also concerned about why are we not able to expand the non-kinetic supply chain in the same way that we've seen with kinetic systems like uncrewed vehicles and with munitions. In large part, this is because we're realizing that U.S. forces are kind of at a fundamental disadvantage against China. We're in their backyard. They have capacity overmatch against us. They, in a lot of ways, get to drive the conflict, if there is one, because they have the initiative. So we're always going to be playing catch up. We're always going to be somewhat behind when it comes to capacity in a confrontation with China. So one way to sort of level the playing field, if you will, is to go after sensing and sense making. How do we reduce their ability to understand what's happening around them, feel confident in the plans that they would pursue? So China's approach is very much with the systems warfare idea that you see on the right-hand side of the screen. We're going to use the reconnaissance intelligence system and the firepower strike system to basically deliver precision weapons on targets across the Western Pacific and threaten to take out a lot of U.S. naval forces and U.S. bases that would be enough to deter us from getting engaged in the conflict. So undermining the ability of that reconnaissance intelligence system to be a confident source of information would be a valuable way of undermining confidence in plans for Chinese leaders. And then when the conflict starts, obviously that's a valuable way to reduce the targeting capability that they bring to bear. So one thing that you've seen a lot in terms of the evolution of U.S. and allied forces, a transition towards passive sensing and multi-static sensing. One thing you don't want to do is reveal ground truth to your opponent by lighting off a monostatic radar that reveals your location. So you see on the screen, there's a bunch of different approaches to this, but you're using background radiation, using your own uncrewed systems as illuminators, using uncrewed systems as sensors, all very important aspects of how do you transition from using radars like the Spy-1, which reveal the location of the ship that's using it, to something where you're trying to hide to the greatest degree possible and you're using background information or you're using reflections from your opponent's sensors or your opponent's communications to try to locate them and then use that for targeting information. Because these passive capabilities are much shorter range, you end up having to get a lot closer to the opponent. Also, you might need multiple views from different angles of the same target. So in a lot of ways, this drives you to uncrewed systems being the predominant sensor platform of the future, because you have to send something close. It has to be scaled enough to be able to do sensing from multiple locations, which means you need more things out there, and they've got to get closer to the enemy, and it's more vulnerable to them. So shifting to uncrewed systems is a way to try to exploit passive sensing more than we have in previous generations of the force. And then you build on that by using electronic warfare systems, jammers, decoys to confuse adversary sensors like signals intelligence satellites, like synthetic aperture radar satellites through jamming or decoying them, and then also going after individual platforms that might come out to investigate the false targets and see what's there, so you can jam and interfere with their ability to see you as well, which drives the need for this non-kinetic supply chain. And then one aspect of this is it has to be an ongoing campaign. So you have to be able to understand what is your opponent thinking about what you're showing them. So you're showing these false pictures essentially to your opponent, and you're trying to understand, well, what do they think of this? How are they interpreting this? Is this working, or do they seem to be able to see through it? And having that diagnostic capability is something that's really important. This is where AI might be able to brought to bear. It's also where OSINT might be very useful to be able to understand what your opponent's thinking or talking about. And so I wanted to ask Skip from Primer AI to talk a little bit about how they use OSINT to do this kind of analysis in support of these kinds of deception efforts, or to see if your opponent is doing the same thing to you.
Thank you. Hi, Skip Farmer, Primer AI. So we're based here in, my division, public sector, based here in Arlington, headquartered in San Francisco. So I summarize a lot of this into cognitive overload that operators, that personnel have in trying to analyze information and turning that into actionable intelligence for whatever the mission may be. So one of the ways we do that, and I think I want to start with what I've been calling kind of the elephant in the room of this, which is misinformation or disinformation. And that nomenclature kind of changing, because that is in the eye of the operator, whoever's doing the analysis, the capability. So shifting that to be more around sentiment analysis, to what Brian was talking about. What is the impact of the information that's coming in? How can we assess and determine the sentiment, positive, negative, neutral, in the context around the entities that are making those statements and sharing that information? So monitoring open source information for that intelligence, whether that's social media, whether that's news sources. There's still a lot of locations where personnel there rely heavily on local media sources and definitely use social media heavily. Being able to analyze that information quickly to determine the narratives as well, so not just the sentiments, but what are they saying, what is being discussed, and that allows for a lot of faster decisions. What's the impact, positive, negative, neutral, again, of a lot of the decisions that are being made. And also want to add into analyzing what's happening on first contact with a lot of this around the technology that might be out there in the field as well. So what I mean by that is our adversaries are describing things they could do. We understand what we think they can do. And then there's a first contact somewhere in a battlefield or in a naval a shipping space where all of a sudden we're saying, well, what is actually happening? What is occurring? What are the people talking about with regards to what they're seeing? And we can very quickly analyze that information to report up, generate sit reps, monitor this on a hourly basis if you need to, generate those situation reports to send it up, and also manage this to some type of COP. Right, so where they may want to overlay this information on top of some other type of information that's coming in around physical components, map that to what they're seeing. And it really expands. The use cases we're seeing initially around the narratives and the sentiment expand to just messaging. It could be around civil unrest as well. It could be around logistics and contested logistics spaces. So initially it starts out maybe non-contested and then of course can expand. So I think there's a variety of ways that we're seeing right now the adoption and adaptability of that technology in this arena, which in some cases I think it's still relatively new about all the different ways that it can be applied and getting that information to the personnel that need to use that. And I think going back to something that was talked about earlier too was how do we make sure junior officers or people that may be a smaller staff can also manage this. And again, talking about the cognitive overload in a way that they can ask questions of the technology. And so when I say ask questions, I think we're all familiar with how you might ask an AI tool, a ChatGPT, things that you use today, ask certain technologies and questions. You want to make sure that they're able to do that in a way that doesn't require detailed prompt engineer training, that doesn't require a whole lot of analyst training to use the tool and technology to get that information quickly, because that would certainly, then defeat that purpose. So you have people that may be experts in their field, they can quickly adapt to the use cases. So adapt the technology, adapt to the use cases, and then view that in a way that makes sense to them in the battlefield space.
Thanks, Skip. I appreciate that. We'll get back to some more of that, I think, later. But so in the study, we go into detail about how do we fix the supply chain, how do we expand it. We propose a new process here where you can improve the throughput, if you will, of non-kinetic effects by creating digital environments where new performers, startups that are doing non-kinetic capabilities can come in and bring those and show them to the government. In the same way we see in the kinetic space, where people will use missile range, White Sands missile range, or Nellis test range, where they can come out and show what they do. We need the same thing digitally to be able to do non-kinetic effects demonstrations for a wider variety of companies. So the study goes into some detail about how that might be constructed. It would cobble together a lot of existing environments that are already being used by DoD. So this is nothing new. It's just making it a more systematic where we make those environments that are currently cordoned off to a particular program or a particular performer and make those available to other providers to come in and demonstrate what they might do with cyber or electronic effects. With that, because I'm going to have to go to a panel, start up here at airspace in about 15 or 20 minutes, and about coming study we have on extending the reach of combat aircraft. So thank you very much.
So as Brian mentioned, we've been conducting a study extending the reach of combat aircraft. Some of you have participated in some of the earlier war games we've held on this subject. This study is informing a separate project we're doing in support of OPNAV 2 on future naval force design, which includes the naval element. It's also informing some other work we're doing in terms of Air Force design. And it's driven by the fact that there are a number of fiscal constraints that are shaping, right, the choices that we need to, where we put our investments to maximize air power. There are also just a number of long-standing constraints on the either physical infrastructure we have to operate our aviation assets from. Air Force aircraft, what airfields you can operate, many of which can be contested. Full aviation aircraft, which aircraft carriers, big deck amphibs, other ships we can operate from. The Ford class is significantly larger than the Nimitz, so that does provide more options. But as we also think about incorporating perhaps a larger FA-XX aircraft onto the carrier, and also try to incorporate perhaps in the future additional uncrewed assets, there are these long-standing limitations that shape how we need to force package. In response, we thought we'd do a project that can look at the broader trade space of options of weapons, combat aircraft, and tankers interactively. And we've been doing this in a few different ways. Some have been through quantitative analyses we've been doing internally, principally using data envelopment analysis, which is a form of multivariate optimization in which we can look at various combinations of combat aircraft, weapons, and tankers, and rigorously assess, well, what's the efficacy of all of these in terms of maximizing the desired output of range in different ways. We've also been doing some effects chain analysis, which Dan Patt and Brian Clark had led a study on metrics to use effects chain analysis in the past, and we're pulling that into this project. And lastly, we've conducted a war game, and I think we're going to do some others. In terms of the data envelopment analysis, these are some of the factors that have stood out as being most consequential. Obviously, procurement and RDT&E costs are quite important, but beyond that, we look on the weapons side. Maximum range was important, but it really wasn't the most important factor. When we look at, in terms of the force packaging of the aircraft and the number of the option combinations that you have, it's more about the range to combat aircraft air-to-air missile capacity ratio, right? Which is commingled with the next element there, which is on the combat aircraft side. You can see it's air-to-air missile capacity and combat radius. This suggests sort of what's maybe straightforward observation, but the data shows us how it's not just how far you can fire with one missile, but how many missiles you can bring to bear. And there's value in having, in some cases, medium-sized missiles that can have longer range because you can carry more of them. That's important so we can take more shots at longer ranges. It's probably also going to be more important in the future as there are a number of countermeasures to our missiles, non-kinetic, perhaps even kinetic in the future. So we will need to be able to take more shots at those longer distances. In terms of tankers, being able to deliver a significant amount of fuel is important in extending the reach of your aircraft, but it's also the fuel burn to burned ratio, right? What's the efficiency of your designs in being able to offload fuel, and then how far back they need to stand back from the combat air patrol or the strike or whatever location where you're going to conduct the final effect. Where that's taking place. Some of our future analysis is going to incorporate more of an effective range metric, which assesses how do these different force packages perform against representative classes of threats and accounts for survivability and lethality against these targets. But this has already started to show some interesting insights. You'll see one of the charts on the preceding slide. This is one snapshot of all these different combinations that we analyzed a number of different ways. And in this one here, you can see at the bottom right, NGAD, FAXX, right, outperform well. You sort of get what you pay for in terms of RDT&E and procurement costs. Conversely, there are other options where, for instance, like F-35B with AATP, it would be a significant amount of money to spend, but in terms of the number of air-to-air missiles you could bring to bear, at least internally, would be modest. So there are pros and cons of different areas. Conducted a war game as well to start to go beyond some of the straightforward optimization and explore how does force packaging and force employment shape some of our thinking. We used it against the scripted red, and some of you participated in that. We're really grateful for your support. And there were a number of insights from that. Wanted to pause, love to get your feedback. If any of you need to head out to make the next panel, please feel free to do so at your leisure. But hopefully this gives you a sense of some of the projects we're working on now, and love to continue the discussion and appreciate your making it out to the breakfast. Thank you, everyone.